Section 1.3 is on square roots. We were simplifying, adding and subtracting, multiplying, dividing, and rationalizing denominators. So I've chosen three. One, to simply simplify, a rationalization because that tends to be the most difficult, and then a subtraction problem, which would be the same as an addition problem. So we've done a couple of different simplifying in class. Remember, there's two ways you can do it. You can multiply now and then simplify, or you can simplify each one individually and multiply them together, but then you need to check to see if it can be simplified further after you multiply it. So I would probably multiply them and see what you get, see if it's something that comes out to be a perfect square, or if it's going to be easy for you to simplify. If it is, do it that way, because then you only have to do it once. If not, then you can go ahead and simplify each one of these separately and then multiply together and then check to see if you need to simplify again. The product of 24 and 6, so when you're multiplying, they don't have to have the same number in order to multiply. You can rewrite it in a single root, 24 times 6 inside. Multiply them. 24 times 6 is 144. And 144 is a perfect square. The square root is 12. So your answer is 12, which ends up being much faster than had you simplified each of them, multiplied together, and simplify again. Second one. Simplify by rationalizing the denominator. Again, there's a couple of ways you can approach it. You could write it as a single root, 50 over 12, and reduce that first to see what you need to rationalize. You could simplify radical 50 by itself, radical 12 by itself, simplify, and then you could rationalize. So I'm going to choose to simplify each one of them separately. The largest perfect square that goes into 50 is 25. So I'm going to rewrite radical 50 as 25 times 2. The largest perfect square that goes into 12 is 4. So I'm going to rewrite 12 as 4 times 3. Remember, one of the two numbers must be a perfect square. So square root of 25 is 5. 2 is not a perfect square, has to stay in the root. 4 is a perfect square, square root of 4 is 2. 3 is not, it needs to stay in the root. You would check now, can you reduce 5 over 2? You can't, so you move on. We are not allowed to have a radical in the denominator. That is not okay right there. That's what we need to fix. And in order to rationalize, you multiply top and bottom by whatever square root is in the denominator. What you want to fix, that's what we multiply by. And as long as you do it on both the bottom and the top, it's the same. So it's like you're multiplying by 1, then it's legal. So when you multiply coefficient by coefficient, 5 times 1 is 5. Root by root, 4 times 3 is 6. So you get 5 square root 6. On the denominator, 2 times the coefficient is 1. 2 times 1 is 2. And multiply radical by radical. 3 times 3 is 9. So if you want to skip writing that step, the square root of 9, you can skip that step if you recognize the square root of 9 is 3. That's how we get rid of the radical in the denominator. We're making it a perfect square. Square root of 9 is 3. 3 times 2 is 6. Once again, just to be sure, see if you can simplify. 5 over 6 doesn't reduce, so you're finished. You can't reduce this one because 1 is a radical, 1 is not. The last one for today, number 15, is a subtraction problem. In order to add and subtract radicals, you have to have the same radicand, the same number inside the root. They are not the same right now, so you can't subtract the way it is. There are times when you're not going to be able to at all, So you're done with the problem. It can't be simplified any further. But you need to look and see if by simplifying you can then make them match. So we can rewrite 32. Largest perfect square that goes into 32, don't use 4 times 8. Yes, 4 is a perfect square. It is not the largest perfect square that goes into 32. 32, I'm going to write as 16 times 2. There are no perfect squares in 2, so I cannot simplify that any further. Square root of 16 is 4. So multiply 5 times 4 is 20 root 2 minus 15 root 2. Now that the radicands match, now you can subtract. When you subtract, it's kind of like subtracting 20x minus 15x. You don't change the root. It stays the same. It has to match to add or subtract, but once you make the match, you don't do anything else with them. When you subtract coefficients. So 20 minus 15 is 5 radical 2. Section 1.4, simplifying algebraic expressions. Number 17 just says to simplify. I put this one in here because you're subtracting, but there's really nothing there. So remember, if it helps to put a 1 there, you need to remember to distribute that negative sign. You're subtracting everything in the parentheses is being subtracted. So if it helps, you can put that as a -1, and then you are distributing the -1 through. So you get 5. -1 times 3 is -3m. -1 times 2 is -2n. There are no like terms. You have a constant, an m, and an n. No like terms. There's nothing to combine. That's as simplified as far as you can. And number 2 is to evaluate. Remember, evaluate means you're going to actually get a number for an answer. So here we have an expression, and then they give us values for u and v. We are going to substitute those values into the expression and then simplify, reduce to get an answer. So I'm going to put 4 in for u, 4 squared, minus, put 2 in for v, 2 squared over u is 4 times v is 2. So 4 squared is 16 minus 2 squared is 4 over 8. 16 minus 5 is 12. 12 over 8 is not going to be a whole number, but we can reduce it. 4 goes into both 12 and 8. So 12 divided by 4 is 3. And 8 divided by 4 is 2. So that reduces to 3/2.